Today we're going to review solving inequalities. An inequality, you guys, is just a fancy equal sign. If you know how to solve an equation, you know how to solve an inequality. So I would maybe take a little note somewhere, I don't know, on the back of your worksheet or something. So an inequality just is a fancy equal sign. So look at number 1. We have 0, and that is greater than 3x minus 3 minus 6. Now, the alligator, if you have heard it back in the good old days, the alligator eats the bigger thing. And we always look at this from left to right. A lot of people get that confused. From left to right, so 0 is greater than all this stuff. Now, this is literally the exact same thing as 0 is equal to 3x minus 3 minus 6. Do you see how this and this are almost the same thing? This is just a fancy equal sign. The only difference is if, when solving for x, if you multiply or divide both sides by a negative, you must change the sign of the inequality. So if it was this way and we multiply by a negative, we'll change it this way. Does everybody remember that from back in the good old days? Okay, let's solve this one then. So solving for x, shouldn't we combine like terms over here? 0 is greater than 3x minus 9. So solve for x. Add 9. So we have 9 is greater than 3x, then we'll divide by 3. Did we ever divide or multiply by a negative? And once again, what people will get confused on is if they subtract something, they'll change the sign, but that's okay. You don't do that. So we have, let's write it in the correct order. 3 is greater than x. Isn't that true? 3 is greater than x. So let's reorder it in the correct order. X is less than 3. Isn't 3 greater than x the same thing as x less than 3? Yes, right? Because it's still eating 3? Okay. So now we'll graph it on a number line. Now here's what you're doing so that you understand why you're graphing it. Our solution is not only, it's all x values less than 3. Does everybody understand that? So isn't -1 a solution? Isn't that less than 3? Isn't 0 a solution? Do you all understand how that's working? So on an ACT, I've seen them say which point is the solution or what is the solution, and they won't give you an interval. So like, would 6 be a solution? No. Would -2 be a solution? Yes. Okay. So go to 3. It doesn't include 3. It's got to be less than 3. So open circle. All of those values are our solutions. All of those x values are the solutions. So on an xy chart, x is this way, y is this way. We're just talking x values that are solutions for this. So x values less than 3 would be 2, 1, 0, -1, -2. Those are all solutions. Yes. But we solved for x. We're finding the x values. We're solving it. So this will work for x values greater than, or sorry, less than 3. So let me tell you how you would write it in interval notation. What is in our domain? Domain is x values. So everybody, let's think more advancedly now, because you could see it as an interval notation. -infinity up to 3, correct? Let's write it in interval notation, yes. -infinity up to 3. Does it include 3? No, so parentheses, parentheses. Question, pretty simple? Yes. Yep, or, so think about why that is. Greater than or equal to 3, so that's why I would close it off. Equal to 3 is okay in our solution. Very good question. Okay, let's do number 6. So it says, so we're solving for p. What makes this a true statement? So let's combine like terms. 2p minus 4p is -2p's. -2p's is less than or equal to -2. Now we're solving for p, so my next step will be divide by -2. Oh, guess what? We just divided by a negative. So we have p, this has got to switch, is greater than or equal to 1. Those are in our solution. If anyone cares why we switch the signs, I can explain. Does anyone care why or not really? If you're in honors, you'd care, so I'm asking. So here's technically why. Ready to watch. If you're dealing with an inequality, we could have done this 2 different ways. We could have divided by -2, or if we don't want to divide by negatives, what we should have done is use algebra where we're not dividing or multiplying. Couldn't we add 2p? Add 2p? And then add 2? Add 2. So we really have 2 is less than or equal to 2p. Now solve for p. Divide by 2, divide by 2. 1 is less than or equal to p. So p is greater than or equal to 1. So that's why we switch it. It's because technically, mathematically, we always get things that are negative on the other side. Does that make sense, everybody? Sweet. So now we'll graph that. Those are in our solution. Any p-value that's greater than or equal to 1. So go to 1. Equal to 1 is okay. So right on 1 is okay. It's in our domain. And x value is greater than that. 1's greater, 2 is greater than 1. 3 is greater than 1. Those are all in our domain. So our domain would be 1 to infinity, including 1. Okay, any questions? Okay, last two examples, and I'll just give you the rest of the time to go for it. Yes. Be this or equal to. Yeah. So our answers are p value is greater than 1 or p value is equal to 1. That sign, that underline means or equal to 1, so we have to close it off to say that includes 1. That's in our solution. Good question. Yeah. Open circle so then it doesn't start at 1, but after that it works. Okay, a compound inequality. These are two key features that you need to remember. You will see an inequality of one sort or another on your ACT guaranteed. So everybody, a compound inequality is just basically when you have two solutions at once. Now there's one important difference. There's the word and versus or. So and is both at the same time. It's the intersection of both. I call it picky. So for example, if you're let's say that you are getting Christmas presents and you go to your parents and say, I want this and this and this and this. You want all of them at the same, you want everything, correct? But if you're not picky, then you go to them and say, I want this or this or this. So not picky, they can get you either or. Does that make sense, everybody? So or is not picky. So either or works, and then this one you need both. So both is at the same time, it's the intersection of both. So if it's in your solution, it has to be the intersection of them happening at the same time. The only time it's a solution is if both have that same answer. And then or is either answer gets to come. If you have this answer gets to come, this answer gets to come. All is welcome. Does everybody understand the difference? So let's do number 7. You could see this split up or put together. So this one's all put together. So basically just treat those like equal signs and solve for n. Get n alone in the middle. So our first step will be to add 12 to both sides. You got to do it to both sides of the equation. So we have two equations in one here. So we have, what's negative 33 plus 12? Negative what?
Negative 19.
Okay, negative 21 is less than or equal to. We have negative 7n, and then we have plus 0, and then we have is less than negative 26 plus 12. Okay, are we all following? Now we're solving for n. Now that was adding a negative, which is totally fine. No, we were just adding something, but you can subtract something too. Okay, now we're dividing by negative 7. Okay, we've got to be careful here. We just divided by a negative. So we've got to change the inequalities. So we have positive 3, correct? Positive 3. Now this will change greater than or equal to. Our n is in the middle. This has got to change greater than 2. So we can split this up, but the way it's written is great. So we want n values. I'm going to reorder this. So we want n values that are greater than 2, but less than or equal to 3. Does everybody see how the less than works out the same here? I can just see it. Do you get why? Less than, if I rewrote it, that doesn't confuse anybody? Okay, between 2 and 3. It says n value is greater than 2, but less than 3. So on a number line, here it is, greater than 2, so locate 2. Greater than 2, so above 2, but at the same time less than 3. Oh, so it's between 2 and 3. Now we've got to put a open bracket because it doesn't include 2. An open circle because it doesn't include 2, correct? So right here we'll put an open circle. So our domain, if we were going to write it in interval notation, would be from 2 up to 3, including 3. So it's the intersection of both. Does that make sense, everybody? Okay. All right. Let's do last example here. So looking at this one, it's an or. Notice how it's split apart. So just solve both and then graph both answers and they both all get a come. Because or is everybody's welcome. All answers are welcome. Solve for n. So we'll subtract 1, subtract 1. So n is less than or equal to -4, right? Over here we're solving. Divide by -4, divide by -4. Oh, I just divided by a negative. N is greater than 2. Now, or is anybody can come. This answer can come and this answer can come. So, n value is less than -4, so below -4, and it's a closed circle because it includes -4. N value is less than 4. Does everybody see why that's a solution? Now, also, n value is greater than 2. That gets to come, not including 2. So those are also in our domain. N value is greater than 2, not including 2. What? Yep, that's an open circle. Good. Does everybody see how now we've graphed this? So our domain written in interval notation would be -infinity up to -4, including -4. Union, that means and 2, not including 2, to positive infinity. Those are in our domain in interval notation. Does everybody understand? So let me just show you what an example would be of no solution. I'm going to now, does everybody understand that before I move on? Yeah. I'm going to change the word or to and. We solve this. I graph them. Do they ever, and is picky, it has to be both at the same time where they intersect. Do these ever intersect? No, so this would be an example of a no solution. Because there's nothing where they both, if that was and, does that make sense? They never intersect. Yeah, but I changed the or to an and, making this a whole new problem. So do you see what I'm saying? If this was and, then it has to be where they intersect. Do they ever intersect? No. So there'd be no solution. Okay, questions on and versus or. Or, everybody's welcome, both answers are welcome. And is picky, it's the intersection of them both. Okay, awesome. That is it. So finish that worksheet, hand it in. Get out your ACT test prep. I might talk to you about a few things and then, yeah. Thank you. So here's the hardest thing for people is setting these up. You've got to be able to set these up. So I want all eyes on me. If you're still working on this, maybe I'll even take some off if I feel like everybody's listening, and I'll take some off and not make you do as much. Okay, so it says the product of 3 consecutive numbers is 120. What's the largest number? You do not want to guess and check this. You will waste all your time on your ACT. This is a problem that is not hard. You should get this one right on your ACT. So first of all, you'll have to set yourself up a true statement. Do we know what the first number is? Yeah. No, we don't. We have no idea, right? So we'll call our first number X. Does everybody understand? Consecutive is our key word. Consecutive means one comes right after the next. So an example of consecutive are 2, 3, and 4. Are they each one greater than the next? So our next number would be X plus one more. One more than this, correct? A consecutive. And then our third number will be 2 more than X. Does everybody understand how that makes them consecutive? 2, 3, and 4. Okay. So X plus 2 is our third consecutive number. Now here's the key word, product. Product means multiplication. So it says product of 3 consecutive numbers. We don't know what the consecutive numbers are, but we've made them consecutive. X times X plus 1 times X plus 2. The product of those consecutive numbers is equal to 120. There's our true statement. Now we need to solve for X. Do I want to go through and multiply this out and try to solve algebraically? I don't. I'm going to use my graphing calculator. So pull up your graphing calculator. Let me show you this. This is so cool. We want to know when does this function equal this function, correct? So type into your calculator. Go to y equals. Go to y equals. Type in x times x plus 1 times x plus 2 into y1. So go to y equals. You got to be in the graphing. So you'll type in x times x plus 1 times x plus 2. When does that function equal, and you can't type in that, in y2, you're going to type in 120. Now think about it. straight line up to 120, our y values need to be at least as high up as 120, correct? We need to see in our window as high up as 120. So if I graph this right now, notice look at the graph. I can't see anything. I can't see this line. Well, so I need to make my window better. Go to window, go to y max. We need to see as high up as 120. So let's do 150. That means we can see as high up as 150 on the y value. I don't need to change anything else. I hit graph. Now, do you see where this function intersects this function? Right there. Now, at what x value? To second trace. Go to intersect, because you're going to want to use your calculator. I've seen ones on the ACT be like 72 is the x. So you'll do, and in your window, you also have to be able to see where they intersect. So let's say that in our window, we couldn't see where they're intersecting. So make your x values bigger. Anyways, so hit intersect. First curve, we're on the first line, we're on the first cubic, I should say. We hit enter. Then it says second curve. It's already on the line, so we're good. Hit enter. Really, your calculator should do all the work on this one for you. Do you want me to guess where they're intersecting? We do. Hit enter. It's intersecting at x equals 4. Now, obviously, y will be 120 because that's where our line is. So at x equals 4, we are up at 120. So x equals 4 was the solution. Now, make sure you answer the question correctly on your ACT. X equals 4. It says, what is the largest number? On the ACT, they will have the option 4. If you click choose 4, you're going to get it wrong. What's the largest number? Isn't x 4? So this is 5. So this is, so our largest number would be 6. That's the one we need to circle. Everybody good? Okay, now let's look at the wording different here. This is another one I've seen on a different person's ACT. Same idea. It says the sum of x plus 2, and x minus 9 is 6. Doesn't sum mean addition. So x plus 2 plus x minus 9 equals 6. What are the three numbers? Solve for x. X plus x is 3 x's. Negative 9 plus 2 is negative 7 equals 6. Solve for x. Add 7. I swear I made this problem up and I thought I did it prettier. Did I make an error? Okay, so our answer didn't come out pretty. X equals 13. So 13 and then 13 plus 2 and 13 minus 9 would be our answers. I made this one up. I thought I made it come out pretty. That would be our answers, right? Okay. Okay, so last one. Oh, almost last one. Given this function, isn't the function in factored form? It says, what are the zeros? Doesn't that mean what are the solutions? What are the x-intercepts? Since it's factored, isn't it easy to find those? What are they? Okay, now let's go backwards. If I said to you, the solutions of a cubic are 0, 2, and negative 1. What is the equation? You work backwards, right? So don't we work backwards? X equals 0, subtract 2. X minus 2 was the linear factor if that was the solution. Add 1. X plus 1 was a linear factor if that was the solution. Ding, ding, ding. Yeah? Now, if I said to you, I want the answer in standard form, you would then say, okay, I can do that. I need to multiply them together, correct? I would not distribute x to here and here. That would be wrong. Just multiply those two together, combine like terms, and then distribute an x to all of that. Does everybody understand? Okay. Last thing, find the area of the grass. This one's quick, way quick. Here's my green grass. Shouldn't I find the area of the whole thing and pretend like the pool and the underground tramp aren't there? Yes. So what's the area of the whole grass? 4. X times area of the square, or a rectangle is length times width. 4x times 2x, which is? Okay, that's the area of the entire grass. So I'm going to write grass with nothing on it. Now let's subtract off the area of the pool. And let's subtract off the area of the tramp, right? Makes sense, right? So we're going to have 8x squared minus 2x squared, right? And then minus area of a circle. You've got to have this memorized before going into a test. Pi times the radius squared. So pi times 5 squared, which is 25 pi, right? So we're going to do 8x squared minus 2x squared minus 25 pi. Combine what you can. Those can combine, correct? So we have 6x squared minus 25 pi. Leave your answer in terms of pi. That's all we can do. That was very easy, but you just have to be able to think. Okay. That's it. So the rest of the time is yours. Make sure you hand in your ACT prep number 1 at the end of the hour. So I would get to that if I haven't finished that. And then maybe take the inequality one as homework.